So hi guys, Pete Shersby here from Make or Repair, and still just going through all the junk in my lab, trying to tidy up a little bit, and I've come to these. So some of you may remember them from a comparison I did against a proper expensive set of desoldering tweezers, because that's what these are. They are a Yihua 938d set of desoldering tweezers, and I did manage to get a few things off the board with them but I certainly wouldn't recommend spending £30 or £40 on a pair of these. So I've decided I'm just going to tear them down and then I'll just reclaim a couple of bits. I do have some other soldering irons that these tips, for example, would fit on, and in the odd occasion that I need a pointed tip that's offset, maybe, you know, who knows, maybe that'll be helpful. And yeah, well, we'll just see what things are like when I start tearing it apart. I do feel a little bit like the EEV blog here, because we're just taking everything apart. I've no idea how these come apart. I'll start at the other end. Okay, so we've got 4 screws. None of this Phillips rubbish, these are posi drives. Kind of, there we go. Yep. Okay, cool. So we're all through hole and here, so that's restrained pretty well. So 3-core cable, so you've got the right colours. It's going in, it's been gripped quite tightly, and then it's got another strain relief there for when it's wiggled around. Let me just see if I can zoom in on that. And I'm hoping you can just see how crusty that soldered connection is. I mean, it's actually got a hole through the side of it. It is so bad. Okay, here we go. Let's separate the 2 halves. Zoom back out again. There we go. Oh, the knob fell off. Okay, I'll just cut that for the minute then. And then we've got a typical low voltage crappy splice switch in the top here, which is fastened through with screws from underneath this decal just here, which is just a sticky pad, and it's actually sticky on the inside. Makes it come apart easy though. But yeah, we'll just pop that out. Easy. I would like to try and do this so that you can still see what I'm doing on the camera, but wire out the way, and there's a earth lead running right across it. So the earth lead actually doesn't earth onto the board at all. It goes straight from the mains and has a little just soldered connection. This is obviously a destructive teardown. I'm actually just interested to see if there's a resistor in there. I could just nope. There you go. Just wind it round and stick a bit of solder on joint. And while I'm here, I'm just going to disconnect the live. So the switch was only in the live; it wasn't a dual pole switch at all. Okay, that's the mains cable out of the way. And I'll just unplug this plug and this plug, so we've just got the board. Okay, so I'm not going to go through the whole circuit here, but I will point out a few things. The first being, I really need a proper pointer, but anyway, let's see what we can do with my scalpel blade. Yay! So live and neutral come in at the bottom here and here, and here's an interesting thought. So the live wire comes directly in from the mains socket, mains wire, and goes straight off to the switch. And then this red wire comes back from the switch and connects to the neutral connection on the board. And the blue neutral goes straight on without a switch to the live connection on the board. So straight away they've reversed the live and neutral. Of course, doesn't stop this functioning, but it does of course mean all of your rectification is in the wrong lead, etc., etc. So yeah, it's a piece of crap, right? And of course, this is QC passed. They didn't notice they connected the mains the wrong way. Hey. What do we have? Well, our live goes through a little fuse down at the bottom there, so just a PCB mounting fuse. And then we've got a bit of capacitance going on. Can't quite see the rating on these. They're 400 volts. This goes pretty much immediately through these two resistors, so that's two 33 ohm resistors in parallel. We've got a half wave bridge rectifier going on here and a Xeno diode for some regulation. And there's not much going on really. I mean, we're just stepping down the main voltage in order to drive these ICs. The ICs themselves, this main one, which is the processor, of course, this is an S3, let me just find the datasheet, yep, an S3F94C4. So an S3F94C4. So it's got a 4K memory. It has a few analog to digital converters. And if we follow the money from this pot here, which is the temperature control, literally that just goes through a resistor and straight into one of the analog digital converters on the processor chip. So it's literally just sampling a voltage that you've dialed in. It does have pulse width modulation outputs, which are going to be driving this bad boy just here, which is obviously switching the mains and switching the voltage on and off to the soldering iron tips. What else have we got? We've got an operational amplifier here, which is presumably just buffering the temperature sensors in the tips, and a display which is being driven directly from the microcontroller. So there's not really very much going on here. This is all through hole. Most of the soldering is all right. It looks like it might have been done, a lot of it manually, a lot of folded over leads, a lot of flux left on the back of the board in various places, all around here. So it's not very pleasant at all, really. The display isn't very clever. It's not helped by the fact that they've left the factory sheet on the front. But as I recall from seeing this run, the displays don't light up evenly. One of them is very faint, and you know, they all appear to be as equally badly soldered, so I don't think that's the problem. Let's see if I can see the part number on here. It doesn't look like they've hidden it, but it looks like it might have a bit of gunge on it that's made it impossible to read. I'm just trying to get the, I mean, you may be able to see that on the camera. It's an NXP. Let's try that as a part number BT137600E. So this is a TRIAC. 600 volts, hence the 600E. 8 amps. Yeah. So the sort of thing you'd expect to find for switching a mains powered soldering iron element. Okay. Well, what else have we got in here? So the only other device of interest in here is this one just here. And this is a CT3041, is a TRIAC, but it's optically coupled and zero crossing. So it's a zero crossing photo TRIAC. It's in a 6-pin package, but only 4 of those pins are actually used. So yeah, so that's pretty nice. That gives you some isolation. I don't quite know why they are trying to isolate that quite so well, given the fact that actually this is a non-isolated circuit in its own right anyway. So there's nothing else there really. Oh, there's a little transistor driver down there. That'll just be driving the TRIAC just here. So yeah, so they stuck it all together, stuck a couple of big wattage capacitors on there, Stuck a few large voltage capacitors on here which do not have an X rating. So this is a 0.1 microfarad, and it is not X2 rated or anything like that. Same with the other one next to it. Not saying that it's not going to work where it is, but safety wise it isn't the appropriate component. It has not been qualified for use in that position on the board. Yeah, nothing else to see. So the cable itself, running up to the soldering iron head, it's actually quite rubbery. It's nice and flexible. You know, no problems with that at all. And I suspect it may well be heat resistance, although there are no markings on it. But I'll certainly be having that bit of cable off to reuse for something. Now for the challenge. How the hell do I get in this? Let's start by taking the tips off, and as I say, these I think will fit soldering irons that I have got, which I would be willing to donate to people, and will do so at some point in the future when I've got thousands of viewers. But yeah, just for the odd occasion, a soldering iron tip that can reach over and get into things can be quite useful. So I will hang on to those soldering iron tips. Here are the actual cartridges themselves, and I'm hoping that if I unscrew these here, that it will continue to come apart. Let's see what happens if I unscrew this adjuster screw from the side. Absolutely nothing happens. There we go. Right, we're in. So, for those who've seen the review, I did mention the sideways movement of the tips relative to each other, and we can see why here, because this is such a poor hinged joint at the back here. I wonder if it would be possible to actually just tighten that up. It's still not great. But yeah, so if you've got one of these and you're using it, take it out of its sleeve and just tighten that joint up a little bit, and that will reduce the amount of play that you have between the tips. So yeah, it's only a millimetre now, which is much better. I'd have given it a better review if they'd tightened the nut up enough. It's not a lock nut, it's not going to stay in position. You could replace that with a, I think this is a 4mm screw, so that little nut just here, if you replace that with a nylon lock nut, tighten that up pretty tight, obviously not so tight that it prevents things turning, then yeah, the give that you get left and right on there reduces very, very considerably. At the hinge, and clearly our wire just goes into here and then loops back out to the other one. Let's take these two covers off. Okay, so wow, I'm not seeing much going on there. So if you do need to replace this ceramic cartridge on these, you'd have to take the entire board out and solder it on. It's not replaceable. Okay, this looks more hopeful. We've just got a couple of screws at the back here that just need to come out. This will be a little cable clip, I think. Yes, it is. Come on. There we go. move that out of the way. Okay, cool. So, cables coming in. We've got a few flat connectors. Big flat connector here with the, is that a 6-way cable running onto it? Yeah, 6-way cable. Then it comes off and we've just got 3 ways going to the other tip. So, what have we got? We've got a plus and minus going into the element here, just the same as on this one. Is that the red wire follow the money up, goes to the spring. Now the spring is what is providing you with your earth in contact through this. So that's pressing against that spring to get its earth connection onto here, and then the screw thread is transferring your earth connection onto the actual soldering iron tip. So red for earth, great. Then green and black are coming in these 2 end ones. So this is literally just a connection to the element and an earth. Slightly. Yeah, okay. So red is connected. It is labelled earth on here, the red cable. Let's see if we can just zoom in a bit just so you can see that, hopefully. Yep, so red goes to earth. Obvious colour choice. Let's get that out of the way. Okay. So now we're just left with this last board. This does have a tiny bit more going on this board. Interesting, we've got a label here, sleep. We've got the same type of connection to the element that we had on the previous one. Same type of connection to earth. Yeah, follow the money to that. It does go to the earth, so that's always good news. Just going through to the element, and then we've got an additional connector here, this blue one, which is presumably the thermocouple. One side of which goes to earth. And the other side is very hard to trace. I will see if I can find where that goes. Okay, it goes to S. Yeah, S1 plus. So that's presumably for sensor then. Okay, cool. So not much going on there. We've got a component on the back. I'm guessing it's a capacitor or something. But it appears to have a clear top with a hole, clear plastic top with a hole in it. Hopefully that was instructional. Safety wise, I'm totally unconvinced. I particularly like the fact that we start off, the first thing we see is the reversal of the live and neutral, and some very poor connections and some incorrectly rated capacitors. And then we're just literally switching on and off the mains coming through to the tip. We clearly do have some sort of thermal detector there feeding back. Yeah, on the positive side, the switching is actually 0 switched, so we're not going to see loads of main spikes and things like that on our supplies. Soldering quality pretty poor. QC passed, which means that it isn't. The handle's awful. It's just cheap, crappy plastic. If you do own one of these, you can improve it by taking the handle apart. So for that, just remove this big adjuster screw and then push on the cable on the back, which has no relief gland, nothing on it. The whole internals will come out. You can just tighten up that nut and it will improve the sloppiness of the handles. So anyway, there you go. Hopefully that was instructional in some way for you. I will just strip out the spare parts, from this now, there's not much that I'll want. I'll take the display just in case I need one in the future, and the controller, and yeah, not a lot else. I think, yes, maybe the cable. I'll just stick a soldering iron on it and see if it is truly heat resistant. If it is, I'll hang on to it. But other than that, yeah, there's nothing much in here and nothing worth keeping. So if you got something from that, if you enjoyed it at all, then please give it a thumbs up. And of course, if you haven't already done so, please subscribe. Leave some comments down below if you like, and I'll see you next time. Take care in the meantime.